In this video, I'll be going through another set of questions, and then I'll be providing the answers and the method in which I arrived at the answers too. So the first one is, you have been asked, classify the reaction. You've been asked to classify the following reaction. You have to go and check your classifications of chemical reactions. Here you have lithium replaces chlorine, while chromium replaces lithium, right? So it is a replacement. It is double replacement. Right, the next question. How many moles of water will be formed? They're asking moles of water formed when 8 moles of NH3 are reacted. So they're given the formula, but always it is good to check whether it is a balanced equation. If not, you have to balance it. So let us see, we have for nitrogen, 4 and 3, 12, 6 oxygen, everything's fine, balanced. They have also given molecular masses underneath, 17.03, 32, 28.02, 18.02. They're asking, when 8 moles of ammonia reacted, how many moles? So this, look at the stoichiometry balance. You have, when you have 6 moles, have 4 moles, so write down the one reactant and one product that we are interested in. The ratios of the balanced equation, 4 to 6. 1 would give 6 over 4, and 6 over 4 times 8. That means it should be 12 moles. 12 moles. That's how we do it. You just get the ratio. 4 moles produce 6 moles. 1 mole will produce 6 over 4, and 8 would be multiply that by 8. Okay. So how many grams? They're asking how many grams of HNO3 will be formed when 8.25 grams of NO2 there. So they give the reaction 3NO2 HNO3 plus N. So see whether it's balanced. 3 nitrogen here. We have 2 and plus 1, 3. Oxygen 6 and 7. We have 6 plus 7. Hydrogen 2, hydrogen 2, so everything's balanced. They're given again the molecular masses 46.01, 18.02. Like last question, you didn't need these things, but they have given. We use them only if you need them. Okay, but 8.2 grams of NO2, right? So first of all, NO2, this is about NO2 and HNO3. When it is balanced, the ratio is 3 to 2. So if we know the amount of moles in 8.25, we can put the same formula. You know how many moles are there in 25 grams of NO2 divided by the mass of NO2. Given molar mass here. So 8.25 divided by 46.01. I get 8.25 divided by 46.01. I get 0.179. We'll say 0.18. Okay. So now 1 would give, I come back to here, 2/3 of moles of HNO3. So 0.18 would give 2/3 times 2 divided by 3 times 0.18. I get, oh, they're asking how many grams. Okay, so I get 0.12 grams, sorry, moles. Now I have to convert it to grams. To do that, I multiply by 63.02. So 0.12 times 63.02, 0.12 times 63.02, 0.12 times 63.02, I get 7.56 grams. So that's the answer. All right. Okay, now determine the percent yield. Percent yield of CS2. When the reaction, when 40 grams of carbon were used, but only 36 grams of CS2 were produced. Okay, percentage yield. Now, when you use 40 grams, only 36. Normally, we should know from 40 grams. In this case, I assume that more should be produced, but actually, the experiment, they got on 36. So let us say theoretically how many grams should be produced first. Okay, because they're asking the percentage yield. Okay, all right. So now they have given the reaction 5C plus 2SO2 giving CS2 plus 4CO. Given the molecular mass is also 12.01, 64.6, 76.13, 28.01. Okay, so carbon, it's about carbon and CS2. So let me write here carbon and CS2. Okay, so the ratio 5 produce 1. Okay, so 1 would produce 1 over 5, 1/5 of the carbon number of moles. But in 40 grams of carbon, we had to see the number of moles divided by the molar mass of carbon, which is given here. So 40 divided by 12. I get 3.33. Okay. So 1 mole would give 1/5. 3.33 moles would give 1/5 of 3.33. That means 0.66. Okay, it's a 0.67 moles. So let us see the mass of this first of all. 0.67. What do you do? CS2 is 76.3, 76.13. You multiply by the number of moles, 0.67. So 0.67 times 76.13 0.67, I get 51 grams. See, we should have got 51, but theoretically we should have got 51 grams, right? So theoretically, because when it is balanced, the balance equation gives us 5 moles of carbon would give 1 mole of CS2. So 1 mole would give 1/5 of CS2. Then for 40 grams, we divide by the molar mass of carbon and got it as 3.33 moles. 40 grams had 3.33 moles. So 3.33 moles should give 1/5 of 3.33, which is 0.67. Okay. Now we need to find that in grams. We multiplied by the molar mass of CS2 and we got 51 grams. So what it says here is, if we had 40 grams, we should have got 51 grams of CS2. If if we had carbon 40 grams, CS2 51, but we got only 36. So that's the percentage yield. 51 means 100%. Okay, but we have got only 36. So 36 divided by 51 times 100, we will know the percentage yield. I get roughly about 71%. That's the yield. So yield means theoretically what should have got, but because it's grams we are talking about, if they say so much reacted with the other, or so much of carbon giving CS2 some amount, we first get the number of moles by dividing by the molar mass. That's what we did here, right? So we got the ratio, we aligned it, then got the moles. Then you convert the amount that theoretically should have got in grams by multiplying by its molar mass of CS2. Now that is 100%. So if we got only 36 grams here, that's all we got. So 36 divided by 51 times 100, we get the yield. Because if 36 was 51, it's 100%. If it was 40, it is higher than 71. It goes on like that. So it's only 71%. Right? The next question. They're asking how many moles bromine, how many moles of bromine are needed to produce 5 moles of Al2Br6. Now they're given the balance equation. Maybe we have to check whether it's balanced before we use it. Al2Br6. So it's the 6 here, Al2 there. It's balanced. The molar mass given as 26.98, 159.8, and 533.4. Okay. How many moles of bromine are needed to produce 2.85 moles? That's asking. So we don't need that. So let us take bromine. It's about bromine and Al2Br6. Okay. From the balance equation, 3 moles will give 1 mole, right? There's nothing. 3 moles will give 1 mole. So 1 would give. Okay. Let me change this because the order, because otherwise you will get confused because they are scaling to produce 2.85. So let me put Al2 here first. Al2Br6. I can't put because it's to produce, so I will put this ratio for bromine. Okay, so the question is 1 mole is produced when we had 3 moles. Okay, asking 2.85. 5, then what? 3 times 2.85, right? Because 1 mole produced 3 times of that. 2.85 will produce 3 times of 2.85. So that would be, you don't need the molar mass for that because they're just asking the moles. So 2.85 times 3, I get 0.55 moles of bromine we need to produce 2.85 because the ratio is 3 bromine. It's producing 1 mole of aluminum bromide. All right. So how many grams, next one, question mark telling how many grams of P4S5 needed to react with 15.5 moles of oxygen. Now, let's again go for this balanced equation plus 10. 10 plus 5 SO2. Okay, this is S. 5 SO2. Okay. Let's balance 4, 4, S5, S5. Oxygen 10, 10, 20, that's 20. Let's balance. And then given the molar masses 284.2, 32, 443.9, and 64.06. Okay, so they're asking how many grams would be produced, or no, how many grams of P4S5 needed to react with 15.5 moles of oxygen. Okay, so they're asking in grams. Now let us see. So this is about oxygen. So SO2. Okay, how many grams are needed? Okay, this is about these two. So I write here. Let me write oxygen first. I'm writing in the best way so that it will not confuse you. So make this combined, right? So you need 10 oxygen, 1 because there's nothing 1 P first. They're asking if it is 15.5 moles, so it is 15. 10 would need only 1 mole. So 1 mole of oxygen would need only 1/10 of P4S5. Then 15.5 would need 1/10 of 15.5 divided by 1. I get 1.55 moles of P4S5. But they're asking grams. All you do is you multiply it by the molar mass given. 284.2. The way you are writing is important, then it won't confuse you. Otherwise, it doesn't matter as long as you can solve it. 284.2. I get roughly 441 grams. So that's the answer. More you do these things, it becomes easier. You see the pattern. Okay. So I have given practice questions, so many practice questions. So how many grams of the next one? Okay. How many grams of iron are needed to produce 35 grams of hydrogen? Now this time not moles, really grams. Now formula again given here, plus 4H2O F3O4 plus 4 hydrogen. Okay, the ratio 3Fe, 3FeO, oxygen 4, and 8. So it's balanced. Molar mass they have given 55.94, 8.02, 231.55, 2.02. So we are talking about ferrous and hydrogen, right? This and that ferrous. How many grams of ferrous are needed to produce hydrogen? So let me put hydrogen first. So the ratio according to the balance equation is 4 hydrogen moles would be produced by 3 moles of F. They're asking how many grams of F we need. So let us first of all do one, produce 1 mole. You need 3/4 of F moles. Let us see how many moles are there in 35 grams. So 35 grams divided by 2, right? 2. On the y, I divided by 2, 2 is this, rounding down. So 35 divided by 2.02, I get 17.32 moles. So here it has 17.32 moles. Now this ratio of 4 moles to produce, we need 3 moles. For 1 mole, we need 3/4. So for 17.32, that means 17.32 divided by 4 times 3. I get 12.99 moles. Right? Now, but they're asking how many grams. So what you do, you multiply by the molar mass, which is 55.94. I get rough 72.6. We'll say roughly 7.727. That's the answer, grams. Okay. Question: how many grams of Fe2O3 can be produced when 40 grams of F are reacted? Grams of oxygen. So let's once again we are given the equation Fe plus 3O2 giving 2 Fe2O3 balance 4 3 and 2 6 6. So oxygen 6 6. So it's right. So molar mass is given as 55.85 32. Okay. Asking how many grams of FeO3 can be produced with that. So it is a ratio between Fe and Fe2O3. Balanced equation would give 4 to 2, 1 into 2. 4, that means 0.5. Okay, we'll say it like 0. Asking if you have 40 grams of Fe are reacted with 40 grams of oxygen. Okay, now this is where the limiting factor comes, right? So you have to do two parts because 40 grams of Fe. Let's see. First of all, find how many moles and how many moles of oxygen here. Right, so we'll separate, find 40 grams. This is for F. 40 grams divided by the molar mass of 55. We get 40 divided by 55.85. We get 0.72 moles, we'll say roughly. Okay. Then for oxygen, we have 40 grams divided by the molar mass 32. 40 divided by 32, I get 40 divided by 32. I get 1.25. Now we know the moles values, right? We know this. So let me because it's not just with ferrous, with oxygen too. So let me bring it up with that. So we have to write separately like ferrous and oxygen to Fe2O3. Okay, because we are trying to see one of them because we have only 0.72 moles of iron and we have only 1.2. We don't know which one is limiting because if we go back to this equation, 4 moles with 3 moles give 2 moles, right? So if you have 6, we'll say 6, it doesn't matter because we have only 4. So 4 would react only with 3. So that limiting factor is what we are going to check. Now, what I have here, we know the ratio 4 give 2 Fe. So 1 would give 2. So if we have 0.72, right? So we have only 0.72 here to react, right? Now, when it comes to the oxygen, it's 3 to 2. Now, the ratio between these two is 4 to 3. So whatever the excess we have, it doesn't matter really, right? They're asking how many grams. So first of all, find out which one is the limiting. Then that is the ratio that is going to count. So let me do this part here. Oxygen 3 giving 1 would be 2/3. Okay. Now we know if I know the number of moles of oxygen here, number of moles, we can see as long as these two balances. Okay. So this is where it is a bit complicated. So we know 0.72 iron there, 1.25. Okay. Now I will write one for iron and oxygen. Okay. Is 4 to 3. So if I have 4 and 3 I need, but if I have 1, I need 3 by 4 when it comes to. So if I have 0.72, I need 3/4 of that 0.72. Okay, we are just following the same pattern. I'm going to see which one is limiting the whole reaction. Okay, so 3 divided by 4 times 0.72. I need only 0.54. So what it means is if I use all the number of moles of iron, which is 0.72, okay, I need only oxygen 0.54. That's all. Do we have 0.54? Yeah, I have 3 more moles there, right? No, I have 40 grams, so I have 1.25. So yeah, I can use this entire moles of oxygen and I get, I use only 0.54. So my limiting, because oxygen is going to be in excess, my limiting is iron. Let us do the other way and see, right? So oxygen, it would have been 3 giving 4, 1 giving. So if I'm using, I got this 1.25 for 1.25 to react, I need 4 ferrous. That means 4 divided by 3 times 5. I need 1.66 Fe. Do we have that? No. Therefore, we stick to this one. We can react the entire 0.72 moles with oxygen and we will still be left with extra, correct? Because we need only 0.54. Now we can, the question is, if you have 40 grams of iron, 40 grams of oxygen, what is the gram of Fe2O3 would be produced? But first we had to know whether all the oxygen, which means 1.25 would react, or all the 0.72. In this case, we know 0.72 iron would react easily with part of this oxygen and the rest would be excess. Okay, so the reactant, the limiting reagent is iron because it's limited. Oxygen would be in excess. So we'll take the limiting one and make our calculation where iron ferric 4 would give 2, 1 would give 2/4, and then if I get the other step, which is 0.72 would give, because we know 0.72, entire 0.72 reacts while oxygen is left. So we have to gauge our ratio according to the one that reacts completely. 0.72 would give 2 divided by 4 times 0.72 moles. We get that. So I get 0.36 moles. So that is the maximum moles we can get when we have only 0.72 iron. Okay, because out of 0.72 only for the oxygen, it reacts, it needs only 0.54. The rest of the oxygen is there, but no point because there is enough iron to react. So the question was how many moles? We got 0.36, but they're asking grams here. So we multiply it by the molar mass, 159.7. Take it at 160. Let me stick to these numbers anyway. So 0.36 times 1. I get 57 point about 4 grams. So that's the answer. Okay, that's how you get it. First of all, when you have two things, but equal amount grams maybe, but it's the molar ratio we look. And take the one that is determined, which is the limiting one by this process. I did it for iron to oxygen, oxygen to iron. Then we know we don't have excess, so this is the. So then that limited one would tell us whatever you get, because this is in excess is not fine because we need more of this to react. So this will determine how many moles of Fe2O3 we are getting, and then I multiply it by the molar mass. It's a bit long, maybe you might think complicated, but look at it several times, then you will see it's not that difficult. This is all calculation, so you might get tired, but it's just practice. Okay, so aluminum oxide is formed when aluminum combines with oxygen. So they say, they give you the reaction telling how the aluminum oxide is made. Okay, and they give molar mass 2732, or dollar in grams, 101.96. Look at whether it's balanced. Yeah, it's balanced. 3 to 6, it's balanced. So aluminum oxide. So how many grams of aluminum? They're asking how many grams would be formed if we had 23.6 grams only. So now again, now you know the method. Aluminum and Al2O3 are the ones we are talking about. The ratio from a balance equation is 4:2. So one would give 4.5, right? Half more. So 23.6 grams, first of all, we need to see how many moles are there. We do it by dividing by 27. These are given one. So 103.6 divided by 27, I get 8.74 moles. So 4 would give 2, 1 would give, always it's half, so 8.74 would be 74. I get 4.37 moles. Moles, but they're asking when you ask how many grams, okay? So multiplied by aluminum oxide 101.96, 101.96 times 101.96, I get 445. So aluminum 422, correct? 1 would be 2 divided by 4. Is half, 8.74. Is it right? No, this number is wrong. I'm sorry, everybody. Just 23.6 divided by 27 can't be. It is 0.87. Okay, so erase it so that no. It's wrong. It's 0.74. It's the point there. So 0.874. We'll see how many moles first of all. That means half of that would be, this will give, we get 3 moles. To see how many grams, multiply by the molar mass again, 0.96. I get about 44.6 grams. That's how we do it. What was there? I missed the decimal. So check your calculator again properly. That's how we do this. All right. Okay, the next question is if 4 moles of BrCl3 reacts according to the equation, how many moles of chlorine? They're asking how many moles of Cl2 produced, how many moles? So we have 2 BrCl3, 3Cl2, and Br2. See whether it's balanced, 2Br, 3Cl6, that's balanced. So the ratio here is, if 4 moles of, okay, so the ratio here is 2 to 3. Okay, we are talking about only these two. So 1 would give 3 over 2, but 4 moles would give 3 times 4, 6. So answer would be 6 moles. The ratio things, okay? Now, if these questions are going to be again the same pattern of what we have done, I won't repeat the same things again and again. Similar patterns, okay? All right. Then the next one, if 3.54 moles BrCl3 reacts with, according to the given equation, how many moles are produced? Again, how many moles of Br2? So 2Br Cl3 plus, sorry, Similar question, but let me do it. 2BrCl3 giving 3Cl2 plus Br2. Okay, is it balanced? 2Br, 2Br, Cl36, Cl36. Okay, Cl6, Cl6. So they're asking if 3.5 moles of BrCl3. So, and with bromine this time. So if you want, you can write it like that, what we did before. The ratio is 2 to 1. Half. So they're asking if you have 3.54 moles, be half of that, right? .54 divided by 2, I get 1.77 moles. Right? So we do that. One. Here they have given the reaction 2 mg plus oxygen giving 2 MgO. What is the limiting reactant? Okay, what is the limiting reactant? Now here standard temperature and pressure is given. There's a reason for that. Okay, we're talking about STP. Think of the what happens STP, right? All 1 mole of any gas would be 22.4 liters. What is the limiting reactant if 2.2 grams of magnesium react with 4.5 liters of oxygen? Liter here, it's gram, gram here, liter here. Okay, they're asking what is the limiting reagent. That means the one that is less. So to find the number of moles here first, 2.2, you divide by the molar mass of magnesium. Now in this case, they haven't given, so you look at the periodic table, and magnesium is 24. So we'll say molar mass of magnesium. I'll write it here so you know what I'm doing. 2.2 divided by 24. 2.2 divided by 24, I get 0.09 moles. Okay, magnesium. Then for oxygen, what happens? Because it's standard temperature and pressure, you 4.5 liters, you divide by 22.4. 4.5 liters divided by 22.4. Then I get the number of moles of that. 4.5 divided by 22.4. It works because it's standard temperature and pressure. Okay, so I get 0.2 moles. All right, now we know the ratios 2 to 1. Okay, so like this is about the magnesium and oxygen. The ratio is 2 to 1. Okay, and we know on the side we have oxygen 0.2 moles. We have magnesium 0.09. We'll do it first for magnesium. If magnesium 2, you get 1. If it is 1, 1 over 2, half. Then if it is 0.9, you get only half of that 0.9. Okay, 0. 0.09. So 0.9, you get 0.45. Okay, moles. So let us see. If we have 0.9, we need only 0.45. Do we have 0.45 here? We have only we have only 0.2. So it's not going to work. If we use all magnesium, we need 0.45 oxygen. We have only 0.2. So it's not going to work. It's going to work because it's 0.09. 0.09. Okay, so it's not 0.09. So if you use 0.09, I need only times 0.09, right? So yeah, let me say it again here, everybody. When I divided first, here, I divided this magnesium mass they gave us 2.2 by the 2.2 by the molar mass. Okay, 2.2 divided by I got 0.09. So magnesium I have only 0.09. For oxygen I did was 0.5 liters divided by 22.4 because it was carried out at standard temperature and pressure. 22.4 is the volume of 1 mole of any gas at standard temperature and pressure. So if I divide the molar volume by any volume, I get the number of moles. So I have 0.2 and 0.09. So if I have 2 magnesium, I need half of that oxygen. But if I have 1 magnesium, 1 mole, I need half. 2, 1. If I have 2, it's 1. If it is 1, half. So if I have 0.09, I would need half of 0.09. So that means 0.09 divided by 2, I get 0.045. So if I use entire magnesium, I need only 0.045 oxygen. We have 0.2. I need only 0.045. 0.045. Okay. Therefore, magnesium is the limiting one. Can you see? Because magnesium, entire thing is reactant. Because we don't have more magnesium only, we can't produce anything else. Oxygen we have in excess. So the question is, what is the limiting reagent? It is now, if I didn't see this one, like we'll say I had only 0.1, then we had to, what I did for magnesium, oxygen, I had to do for oxygen and magnesium and C. Okay. We did similar one before. All right, now the next one, they have given CH4 plus 2H2O, giving 4H2 CO2. Okay, how many liters of hydrogen can be produced? They're asking how many liters of hydrogen. They're asking liters. Okay, when it comes to gases, all are gases, and assume everything is gases, you just get the ratio, right? Let's see. How many liters of hydrogen can be produced if we have 80 grams of CH4 and 16.3 grams of water? Now again, we have to find the limiting reagent like the previous one, and then use that to find the ratio. Okay, so let us find what are these moles in each one. Moles. Now you know I divide 80 grams by the molar mass of CH4. They haven't given. So molar mass of CH4, what you do is carbon is 12, which you should know by now. Carbon is 12, hydrogen is 1, but there are 4 of that. So that is 12 plus 4 times 16. Okay, so 80 divided by 16. I get 5. Okay, now when it comes to water, 16.3 divided by 18. 16.3 divided by 18, I get 9. Okay, now we'll get these ratios together and see where it stands. Okay, is this balanced? CH4 4, 8, carbon 1, oxygen, it's balanced. So let me rewrite here because I had to move this up. So I have CH4, the ratio here, first of all, combine this with 1 to 2. Okay, 1 mole would need to react with 2 moles. So here I have 5 moles of CH4. I would need 2 times 5, 10 moles. We have 10 moles of water. I have only 0.9. I have only 0.9, right? Okay, like that. So I can't react entire CH4. Okay, so let us see the other way. Water to CH4. 2 moles of would react with 1. 1 would react with half of that. So I have here 0.9 moles. So 0.9 will react with half of that. I hope you understand what I'm doing. So 0.9 would react with half of 0.9, which is 0.45. That's all I need CH4. So here, clearly, the entire 0.9 water will react with half of CH4, which is only 0.45. We have 5 moles. So the limiting one is water. Now we'll go here and make up this ratio, because 1 mole, 2 moles, 4 moles of hydrogen and 1 mole of carbon dioxide. They're asking how many liters of hydrogen. But here you can't talk about the liters because number of moles, because water is limited, we determined. So let us take 0.9 moles and do this ratio with water because CH4 is going to be there in abundance. Okay, so to make it and go down to 2. Okay. So now we have water to hydrogen ratio is 2 to 1 to 2, that's right. So if I have 0.9, this will make like 2412.9, will make 1.8 moles of hydrogen. That's what it makes. But they're asking what is it in liters. So assuming this is in standard temperature and pressure, it doesn't say anything. We'll take it like that. 1.8 times 22.4, 22.4, we should get the answer because 1 mole of any gas is 22.4. So now we have 0.8 times 22.4. I get 40.32 liters. So that's the answer. Grams. Question is 50 grams of nitrogen has a volume of what? Has a volume of, so let us find 50 grams divided by molar mass of nitrogen, which is 28. 50 grams divided by 28. How do I know? Nitrogen is 14 times 2. From the periodic table, you get it. So 50 divided by 28, I get 1.79, we'll say, moles. That's a volume of what? At standard temperature and pressure. You multiply it by 22.4. I get roughly 40 liters. So whatever the closest value given, near to 40 is the right answer. Okay. Okay, everybody, I'm doing the final one. They're asking the density of CO2 at ST. So density of CO2, right? What is density? Density is given by mass over volume. So let's say STP, any 1 mole, we have to take it as 1 mole. Volume would be 22.4. Mass would be the molar mass of carbon dioxide, which is 12 plus 2 times 16. 2 times 16 is 32, 34, 44 then. So 44 divided by 22.4 volume, the volume of 1 mole, we have taken the molar mass of CO2, means 1 mole of CO2 is 44 grams. 1 mole of CO2 at standard temperature and pressure is 22.4. Then we should get the density. Let us see, the density is 44 divided by 22.4. I get 1.96. What is this? Grams per liter. Okay. Now, so roughly 2. All right. I hope this has given you some insight into how to do these questions.